This video is for second part of the test for integration technique. Okay, let's do number one. So integral 5 dx over square root 9 minus x squared. So I see that that's an inverse sign, right? So, but before you do that, I need to change the form. So 5 dx. So you can factor out 9 like this. Now, so root 9 is a 3. So 5 over 3 dx 1 minus that's a x over 3 square. Now let's say u sub u is x over 3, then du equals 1 over 3 dx. So that becomes 5 over 3 integral 1 over square root 1 minus u square. And then dx is will be 3 du. So 3 du. But this 3 cancel out. So 5 inverse sine of u and then plus c. So answer E. Okay. Number 2, this one you need to use a power reducing formula. So we talked about that the other video. So you can just change it to 1 plus cosine 2x over 2 dx. So you can split it. 1 half dx plus 1 half, you can take it out, and cosine 2x dx. So this one 1 half x. And then if you consider chain rule in your head, that will be plus 1 over 4. Because derivative 2x, the 2 comes out. So sine 2x and plus c. Okay, so if you look at the answer choices, B will be your final answer. C, so I know when you say u equals tangent, derivative tangent is secant square x dx. Okay, so let's say u equals tangent x, then du is a secant square x dx. So integral u square and du. So 1/3 u cube plus c. And then you substitute back. So tangent x cube plus c. So answer is E. Okay. Number 4. So you can also manipulate it with this one. If you say u equal 1 plus x to the fourth power, it's not going to work because you're going to come out x cubed. But on the numerator, it's not x cubed. So one way you can do, you can switch over 1 plus x square square. And then I'm going to use u sub, okay? So u equals x squared. Then du is a 2x dx. So this portion will be 1 half du. So 1 half you can take it out and du. And 1 plus x squared. I mean u squared. U squared. So 1 half. 1 plus 1 over 1 plus u squared is arctangent, inverse tangent of u. U was x squared plus c. Okay, so then answer C. Okay, let's move on. Inverse sine x dx. So this one you have to use integration by part. So u is inverse sine x, and then dv equal, let's say, dx. Then du is 1 over square root 1 minus x squared dx. V is x. So uv, so x inverse sine x minus a v du square x dx. So here, let's say u equals 1 minus x squared. So then du negative 2x dx. Okay, so x inverse sine x, and then it will be then minus, it will be plus 1 half, because x dx is a negative 1 half du. Okay, so it will be 1 half, and then du and square root u. Okay, It'll change it like that. Now x inverse sine x plus 1/2, that is u to the negative 1/2 du, du. Now when you do power law, 1 over 1 negative 1/2 plus 1 is 1/2. So 1 over 1/2 is 2. So x inverse sine x plus 1/2 times 2, and then u to the 1/2 plus c. Then these two cancel out. So x inverse sine of x plus u was this one, 1 minus x squared, and then you put square root plus c. Oh, actually I need to stop here. Okay, I just went all the way. But answer is then E. Okay, 5 is E. But you can go further. So then your final answer will be this when you take anti-derivative whole thing. Okay, but they didn't ask you. So which form the same. So it should be that one. Now this one, I know my u is a cotangent x. So du is a negative cosecant square x dx. So it comes out nicely. So integral e to the u and negative du. So it will be negative e to the u. So cotangent x plus c. So d will be answer. Just use that. Now, so many questions here. But it kind of overlap the same technique as the other video. So I'm gonna skip around. So let's look at number 10. This one polynomial. So remember, if you have a polynomial numerator and denominator, like rational expression like that, then you do long division, okay? So power, the highest power in the numerator is greater than denominator or equal to, then you use long division. So let's do that. X cubed minus 2x squared minus 15x plus 2 divided by x minus 5. Remember, sometimes when you do long division, if it's a missing term, make sure you put 0, okay? Like what I'm saying is, let's say x squared minus 5, when you divide by, then make sure x squared plus 0x minus 5. You put it like that, okay? Missing term, you have to put 0. So now, so this one x squared then, because x times x squared is x cubed minus a 5x squared. So when you subtract, 3x squared minus 15x. Now plus 3x, right? Because x times 3x is 3x squared minus 15x. When you subtract, 0, and then next one is just 2. So you can rewrite this one integral your quotient x squared plus 3x plus remainder over divisor. Okay, like that. So that's the first step. Now when you take antiderivative, 1/3 x cubed plus 3/2 x squared plus then 2 ln, right? X minus 5 plus c. Okay, yeah. So that should be your final answer. This is a free response, so no answer choices. Okay, and then let's do next one, number 11. So number 11, one way you can do is if you have anything odd power, you have to manipulate that one. So sine 6 power, you keep it like that, but cosine square x and then cosine x dx, you make it even power. And then we know that 1 minus sine square x cosine square x, right? Because sine square x plus cosine square x equals 1. The identity, we talk about it. So I'm gonna replace it. So sine 6 power x, 1 minus sine square x, and cosine x dx. So when you multiply it out, distribute, then sine 6x minus sine 8x, you add the power, and cosine x dx. So let's say u equals sine x. Then du is cosine x dx. So then it will be u to the 6 minus u to the 8, and then du. So 1 over 7 u to the 7 minus 1 over 9 u to the 9 plus c. Now you substitute back. So 1 over 7. My u was a sine x. Sine x to the 7. Or sine 7x. Same thing. Minus 1 over 9. Sine x to the 9 plus c. So that's your final answer. Okay? That's how you're going to do. Next one, let's do number 12. So if you consider Riyadh, right? If you consider Riyadh, then you can see which one is a. So trigonometry comes first, right? Compared to exponential. So u equals cosine x, and dv equals e to the x dx. So this one we call I method. You will see why I call I method. So look, du equals negative sine x dx, and then v is e to the x dx. I mean, just e to the x when you take antiderivative. Now uv, so e to the x cosine x, minus v du, so plus integral e to the x sine x dx. Now one more time. So u equals sine x, dv is e to the x dx. So du is cosine x, v is e to the x. Okay? So then it'll be e to the x cosine x plus uv, so e to the x is sine x, minus v du, integral e to the x cosine x dx. Now, we start from integral e to the x cosine x dx, right? So that is like that. And I realize this one same. So let's put I. Okay? So when you add I both sides, so 2I will be e to the x cosine x plus e to the x sine x. Okay? And then when you divide by 2, and then factor out e to the x, cosine x plus sine x like that, and then plus c. Okay, so that's your final answer. We call I method. You make it I for the same expression, and then you solve for the variable. Okay, that one is something also different. It's very important actually. Most likely you will see on the test in this unit. Now, next one, what I want to do is number 14. So I'm gonna do secant 4x. So then first of all, what you have to do is, let's say u equals 4x, then du equals 4 dx. So integral secant u and 1 over 4 du. Now, what I want you to memorize is this. Integral secant x dx. This one just you need to memorize. Your teacher will give you some things you need to memorize. So this is one of them. Secant x plus tangent x. Okay. You can see how you're gonna derive this one, but you need to multiply like being a huge expression, numerator and denominator. But that one also you have to memorize it to derive it. So it's just like most teachers, they give it to you this one, or you need to memorize it. Okay. So then 1/4, and then all, then secant u, so 4x plus tangent 4x, okay, plus c. That's your final answer. So remember that formula. Secant x, integral secant x dx is ln secant x plus tangent x plus c. Okay. Next one, what I want to do is a 15. So this is pretty simple, but we talk about so many rules, so don't forget this kind of simple one. So u is 4 plus 9x, so du equals 9 dx. So integral u to the 1/2, and then 1 over 9 du, right? So 1 over 9 times 1/2 plus 1 is 3/2. So flip it, 2/3, and then u to the 3/2 plus c. So 2 over 27. U was 4 plus 9x, 3/2 plus c. So that's your final answer. Okay. Now, what I want to do is next one is 17. Okay, let's do 17 here. So let's say u equals e to the x, right? Then du is e to the x dx. Then integral cosine u, and e to the x dx will be du. So there will be sine u plus c. So sine e to the x plus c will be your final answer for number 17. Okay, just use up. Now next one I want to do is number 19. So how you gonna do this one? So this one, if you set 4 minus 2x squared u, then you're gonna stop. Okay, so this one just simply multiply it out. So 4 minus 2x squared and then 4 minus 2x squared, you void it out. So 16 minus, this one minus 8x squared minus 8x squared, so minus 16 x squared plus 4x to the fourth power and dx. So you do power rule minus 16 over 3 x cubed plus 4 over 5 x to the fifth plus c. Okay, then that should be your final answer. And the last one, let's do 20. So let's say u equals ln x. Then du equals 1 over x dx. Okay, and then integral. Then 1 over u du. So ln u plus c. Ln u was ln x, right? Ln x. Make sure you put parentheses and also absolute sign there plus c. So that will be your final answer. But remember, I think I forgot to mention that in the beginning of this video. Make sure all the time you pause the video before you see the how I solve the problem. Make sure you do it on your own and then compare your answer. Okay? Alright, that's it for this video.